In section 6.1, we're going to talk about right triangle trigonometry, and we're going to define 6 trigonometric ratios of acute angles in terms of right triangles, and we're going to learn to evaluate trigonometric ratios using triangles and using a calculator. So angles and degree measure. So first of all, we have degrees, and in each circle we have a total of 360 degrees, whereas a line is 180 degrees, and that's something that we should all be familiar with. And your circle's 360 degrees, so that means that 1 degree is the part of 1 over 360 of an entire circle. Now we can talk about these degrees in minutes and seconds too, and this is called the DMS form. So that's degrees, minutes, and seconds form. When you're talking about the DMS form, then it could be expressed in decimal form, or it could be in minutes and seconds. So let's say we have something like 36.75 degrees. We could also change that from decimal form to DMS form. So a minute, we need to understand, is 1/60th of a degree. And a second is going to be 1/60th of a minute. Okay, so sort of like seconds, hours, and minutes, if you think of it like that. And let's just sort of do something here. So you've got 1 degree. Let's say you have 1 degree. You know that there are 360 degrees in a circle, but if you have 1 degree, then that's going to be equivalent to 60 minutes. Okay, that's equal to 1 degree. And the notation for this minute is going to be just like this. Okay, that's the same. All right, now if you have 60 minutes, then in each of those minutes, then you could break those down into seconds. So 60 minutes is 1 degree, but 60 seconds is equal to 1 minute. Okay, so 60 minutes is 1 degree and 60 seconds is 1 minute. So what that means is that there are 3,600 seconds in 1 degree. And we could get that just by multiplying these two 60s here. All right. And now let's look at going between the different forms that we have. Let's say I have 42. Let's say I have 42 degrees, 30 minutes, and 9 seconds. And we're going to take that and we're going to write it in decimal form. So if we're going to write that in decimal form, then I've got the 42 degrees. Okay. I'm going to add to that the 30. Okay. What you want to think of is what part of a degree are these minutes here, and it's 1/60th. So really you get 30 over 60, or you could think of it, maybe it's easier to think of it, is you've got 30 1/60ths, okay, plus you've got 9, and then, okay, which is going to give us 42 plus 30 over 60, which is a half, plus, and 9 over 3,600, which is going to give us 1 over 400. Okay? And if we simplify that, if we just add these two fractions right here, the 1/2 plus the 1 over 400, then what we're going to get is 0.5025, okay? Plus the 42, it's going to give us 42.5025. Okay, and we have changed that DMS form now to decimal form. All right, now we're going to go the other way. We've got a decimal form and we're moving to DMS form. Okay, so when we do this, we're going to keep our 31 degrees, okay? And we're keeping that for now. And then what we have is we have 0.4125 as our decimal, and we're going to multiply that by 60 to see how many minutes we come up with. When we multiply that by 60, we get 24.75 minutes. Okay? So what that's going to give us then is we've got our 31 degrees. That's going to give us 24 minutes. Okay. Now we're going to take that 0.75 part that we have to find our seconds. And we're going to again multiply by 60 because there are 60 seconds in any 1 minute. And when we multiply that, we get 45. And so that's 45 minutes. I'm sorry, 45 seconds, not 45 minutes. So then when our DMS form is going to be 31 degrees, 24 minutes, and 45 seconds. Okay. All right, now we've talked about DMS form, and we're going to go through now and talk about some special right triangles. This is going to help us out. This is something you should probably remember from geometry, maybe a little bit from algebra 2, but we have two special right triangles that we're going to be using in this chapter. One is the 30-60-90, and the other is the 45-45-90. Now, the relationship is going to be that if you see this triangle here on the left side, then you see a 30-60-90 triangle. And if I have a 30-60-90 triangle, then I like to look at it like this. Opposite the 30-degree angle is going to be your smallest side, your shortest side, because it is the smallest angle. So opposite the 30, we call that one A. Now, if that's A, then our middle length side is going to be opposite our 60, which is here. Now, it is bigger than our A side. And how much bigger? It is √3 bigger. So we take the A and multiply it by √3. So if the A was 5, then opposite the 60 would be 5√3. And then opposite the 90 is going to be also bigger, and it's going to be 2 times A. All right, and then if you're given any one of those, you can find the others. If you need to go up, if you have, let's say you have this one here, opposite the 60, if you need to go up, then you're going to have to divide to find the other one. If you want to go down, you're going to have to multiply. By the factor that they have, by the factor of their factor that's the difference. Okay. And then let's say we have our 45-45-90 triangle. Well, we know whatever's opposite the 45 is going to be the same in both cases. So we're going to say that's x and that's x. Now, of course, whatever's opposite the 90-degree angle is larger, and it is larger by √2. So x √2. Now, you need to understand and you need to be able to memorize those relationships. A little trick I like to remember is this one here. There are 2 different angle measures, so that one uses the √2 in it. And on this one over here, there are 3 different angle measures, so that one uses the √3 in it. Okay? So those are your special right triangles. And now that we know those, let's talk about trigonometric ratios. If you have an acute angle, and we call that angle theta, and let's say that's theta there, the sine of theta is written as the sine of theta is the opposite side over the hypotenuse. So if this is our right triangle here, this is our hypotenuse. If this is theta, then we have our opposite side here, and our adjacent side here. Okay, so sine of theta is going to be the ratio of the opposite to the hypotenuse. Cosine is the adjacent to the hypotenuse, and tangent is opposite over the adjacent, or sine theta over cosine theta. In addition to that, we can actually, let's go back for a second. I want to tell you something to memorize these. Okay, so SOHCAHTOA, this will help you memorize these if you've probably seen this before. But sine, this is sine, is going to be the opposite over the hypotenuse. Cosine is going to be the adjacent over the hypotenuse. And tangent is going to be the opposite over the adjacent. And that will help you memorize it. Okay, now let's go through and look at the reciprocals of each one of those. Okay, cosecant and sine have a relationship, and the relationship is that cosecant is equal to 1 over the sine of theta, or cosecant of theta is equal to 1 over. So what that means is how sine theta was opposite over the hypotenuse. So when we look for cosine, what you do is you take this ratio and you flip it over, so it's hypotenuse over the opposite side. Same thing with secant. Secant has a relationship with cosine, and it was adjacent over hypotenuse for the cosine, so now it's hypotenuse over the adjacent, or 1 over cosine, whenever you find cosine. Cotangent, the same way. Instead of opposite over adjacent, it's adjacent over the opposite, or cosine over sine would also work through. It'll allow you to work through that one. Okay, and here's some things you need to memorize. So let's say we have these 30, 60, 90, and 45, 45, 90 triangles. So let's say that this is our 30-degree angle, right angle, and this is our 60. Okay, and over here, of course, our 90, and then our 45, and our 45. Okay, so for each of those, if you're looking for the sine and the cosine of each of those, then for example, your 30-degree angle here, if you know what those side lengths are, or if you know the relationship, for example, this is x root 3, and this is x, and this is 2x, and then over on the other triangle we have let's say a and a root 2. Okay, and let's say I want to find the sine of my 30-degree angle. Okay, sine we're going to use opposite over hypotenuse, which opposite of that is going to be x, and our hypotenuse is 2x. If we simplify that, we get 1/2, and that's how we get this value here. And these you need to memorize. You could go through and prove each one of these, but it's also something that you need to be very familiar with. You need to memorize these. Okay, and let's try one more so that you can see how it works. Let's try the let's try the cosine of our 30-degree angle. Cosine of our 30-degree angle is going to be the adjacent over the hypotenuse, and the adjacent is going to be x root 3. Our hypotenuse is going to be 2x. We simplify by canceling out our x's, and we get the root 3 over 2. Okay, so the cosine of a 30-degree angle is going to be root 3 over 2. Sine of a 30-degree angle is 1/2. And so you need to know each of these. Okay, now here we have an example, and what we're looking to do is evaluate the 6 trigonometric ratios of the angle theta that's shown here. And let me mark theta. Theta is going to be this angle here. All right, so we want sine. Okay, and we're just going to leave these in fraction form, and that's fine. So the sine is going to be the opposite, which opposite is 4, over the hypotenuse, which is 5. Okay, so we have sine, and while we're doing that, it makes a lot of sense to just go ahead and do the cosecant, and we take the 4 over 5, flip it over, and it's 5/4. Okay, now let's do cosine. Cosine is going to be adjacent over hypotenuse, and the adjacent is going to be 3, hypotenuse is 5. So while we're doing that, let's go ahead and take care of our secant, and it's 5 over 3, hypotenuse over adjacent. And then we have our tangent. Tangent is going to be opposite over adjacent, and our opposite is 4, our adjacent is 3. And so now let's take care of cotangent, and that's 3 over 4. All right. Now you've also heard me say that tangent tangent can also be written. Tangent can be written not using sine and cosine. So we could say sine over cosine. So if I have sine, which is 4 over 5, over our cosine, which is 3 over 5. If I simplify this, hold on, let's not get confused here. If I simplify this, I have 4/5 times 5 over 3. Those cancel, and I get my 4/3. Okay, and that's why tangent and cotangent can be written in terms of sine and cosine. Okay, let's look again at the 6 trig ratios of a 48-degree angle, and what we're going to do is just evaluate these using a calculator, okay? So let's say I have a right angle here, and this is my 48-degree angle, and all of this information will be given to you. This is 4, this is 3.6, and this is 5.4. Everything in black is given to you. And now we're looking to find the 6 trig ratios of this triangle. So we're going to start out by finding the sine of my 48-degree angle. And the sine is going to be opposite over adjacent. I'm sorry, opposite over hypotenuse. So we get 4 over 5.4. And what you want to do, what I'm looking for you to do right now is to plug each of these into your calculator and see that they are the same value. So in each case, you should find out that you get 0.7, approximately 0.74. You're going to have to round that, so we're going to say approximately. Okay. And there's a sign key on your calculator, which is, let's see, let's just show you what I mean here. So okay, so if I do 4 divided by 5.4, I get 0.74, approximately 0.74. Now if I take the sine of 48, I get approximately 0.742. Now they're not exact because I did have to round here. I rounded on each one of these, but there may have been some rounding involved with those side lengths as well, is what it looks like. But if you're not getting, when you take the sine of 48, if you're not getting the 0.74, then likely what's wrong is your calculator is not in the correct mode. So if you hit your mode key here, and you want to go down and look, you're probably in radian mode. So if you go over to degree and press enter, and then go back, and you find the sine of 48 again, you should get your 0.743, da 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 da. So then you could go through and find each one of those, okay? And so we've got the sine of 48. And then while you're taking care of that one, if you want to go ahead and find the cosecant of 48, it's going to be your 5.4 over your 4, and try both of them again, which there's not going to be a cosecant key. We're going to have to use 1 over sine of 48 there. In this case, you're going to get approximately 1.35. Okay? And then try that you should be able to go through and try that for cosine, and I'm going to leave this up to you, tangent, and then, of course, the reciprocals, which are going to be secant and cotangent. Okay. And then the last example we're going to evaluate, let's say I just ask you to evaluate the 6 trigonometric ratios for a 15-degree angle using a calculator. All right, so what you have, you might want to start out by sketching yourself a triangle, a right triangle, and saying, okay, this is going to be my 15-degree angle. Okay, and I'm asked to find the 6 trig ratios of those. So I'm finding the sine of 15 degrees. And this is just a matter of plugging each of these into your calculator. The cosine, 15 degrees. Again, make sure your calculator's in the correct mode. Tangent of your 15 degrees. Okay. And then while you're doing your sine, you might want to go ahead and take care of your cosecant, because in this case, for the cosecant of 15 degrees, there's not a cosecant key, so you're going to have to use 1 over sine of 15 degrees. And find out what that gives you. Okay, the same thing with cosine and tangent, to find your secant, and then to find your cotangent. So you need to go through and find those 6 decimal values there, so that you have the 6 trigonometric ratios for a 15-degree angle. And that's all I have for section 6.1.